All right, so this video is going to cover solving basic trig equations in quadrant one, right? And by quadrant one, well, that of course just means our solutions are all going to be from 0 degrees to 90 degrees, right? So if we've got a circle, our unit circle here, right? Well, we know if we're in quadrant one, we're limited only to here, which of course is well, from 0 degrees up to the y-axis, which would be 90 degrees. We're not worried about any of the rest of this. Okay? So let me erase all this nonsense. And let's get started on some of these solutions. Okay, so here we've got a trig equation 2 sine theta minus 2 equals negative 1, right? And this is analogous to simply saying 2x, meaning this guy here, sine, is x, minus 2 equals negative 1. At least for now it is, right? So what we're really working to do here in the beginning is to get the trig function by itself first. Okay, and that trig function in this case is sine of theta, right? So we're working to get that by itself the same way we would if it was 2x minus 2 equals negative 1. Okay, so what we would do first is we would, well, like I always tell you, work from the outside in, right? So we're going to want to get rid of that minus 2 first by doing its inverse of plus 2, right? So I'm going to have 2x minus 2 plus 2 equals negative 1. What I do to one side, I also do to the other. And that brings me to this. 2x is equal to, because these guys canceled, 1. Or, remember, the x is sine theta. So we can say 2 sine theta is equal to 1, right? Either way, we are working to get the trig function by itself. So I'm going to continue with it just as an x, and in the later examples, you'll know what it is I'm doing. Okay, so obviously I'm going to divide by 2 on both sides. That's going to cancel there. What you do to one side, you do to the other. And we now have x equals 1/2. Or, as we know, sine theta equals 1/2, right? And we're not quite done yet. We still have to undo the trig function, okay? So the inverse of multiplying is dividing, and dividing has an inverse of multiplying. Adding has an inverse of subtracting. Subtracting has an inverse of adding. Sine has an inverse of arc sine, right? So the inverse of sine is arc sine. And what we do to one side, we're going to do to the other. So these guys will cancel. We have theta by itself. I still have to do arc sine of this guy over here. So I'm going to go ahead and say arc sine of 1/2 now. Okay. And if you don't have your table memorized, right, you should know like what angle gives us a sine of 1/2, right? And we know that that's going to be 30 degrees. So our answer here for part A is theta equals 30 degrees. Okay, but if you don't know that, well, you can use a calculator to help you out here. So obviously make sure that you're in degrees mode. Okay, and we're going to hit the trig button. We're not going to select regular sine this time. We're going to select arc sine, and we're going to put 1/2 or 1/2, right? And it tells us the same thing as our trig table would tell us. Okay, so pretty straightforward there, right? So let's do another few examples, and then we'll call this video good. This is actually a really simple concept, especially when we're limited like we are to quadrant one. It gets a lot more gnarly when we're not limited to quadrant one. But if you understand quadrant one, you can understand all the rest of this. No big deal. Okay, so here we're trying to get the trig function by itself, right? So what is making the trig function not be by itself? The division by 2, right? The inverse of which is to multiply by 2. So I'm going to multiply by 2 on both sides. And what I do to one side, I do the other. That brings me here. Cosine theta is equal to 2 square root of 3 over 4. 2 over 4 can reduce to 1/2. So we really have cosine theta is equal to square root of 3 over 2, right? 2 divided by 2 is 1. 4 divided by 2 is 2. Okay? And our final step is like what we did in the previous example. We need to undo cosine. The way we undo that, of course, is to say arc cosine of cosine theta. And what we do to one side, we do to the other. Arc cosine of the square root of 3 over 2. Right? Arc cosine and cosine are going to cancel on this side. That leaves us with theta is equal to, well, whatever the arc cosine, the arc cosine of square root of 3 over 2 is. And again, if you know it on the table, you know it's going to be theta. Theta is going to be equal to 30 degrees. If you don't know it on the table, well, you can do it on the calculator. We're going to do arc cosine, and we're going to say square root of 3 over 2, and there it is. We get the same thing that we ought to know, that we ought to have memorized by now. Okay, and there it is. Pretty straightforward. Let's do another example. Okay, so here first, working from the outside in, right? There's only one thing making tangent not be by itself, and that's that plus 4. So we're just going to do minus 4 to both sides. So we have tangent theta is equal to 1. Then we do the arctangent of both sides. So theta is simply equal to arctangent of 1, right? And I already know what my answer is going to be. I already know theta is going to be 45 degrees because, again, this is a special trig ratio, right? But if you didn't know that, we could do the arctangent of 1 in the calculator, and it gives us the exact same answer. Okay? Let's keep this going. So this one's pretty straightforward. I'm just going to divide by 6 on both sides, right, to get sine theta by itself, right? So I know my next line of work is simply going to be sine theta equals 3 square root of 2 over 6. 3 over 6 reduces down to 1/2. So now I've got sine theta equals square root of 2 over 3, right? Because 3 divided by 3 is 1. 6 divided by 3 is 2. Okay, so now final answer. Theta is going to be equal to, well, this is not a special trig ratio this time. Okay, so now we have to use the calculator. So theta is going to be equal to the arc sine of square root of 2 over 3. No idea what that is off the top of my head. So now we have to use the calculator. So trig button, we're going to say arc sine of square root of 2 over 3. And here we get a non-special angle, because we have a non-special trig ratio, of approximately 28.13 degrees. So theta is approximately 28.13 degrees. Okay, a few more examples. Okay, so here all we're going to have to do is divide by 5 on both sides, right? Because we're trying to get the trig function by itself. The thing making it not be by itself is the multiplication by 5, right? So we just divide by 5 on both sides, and we have cosine theta is equal to 1 over 5. Then we do the arc cosine on both sides. So theta is simply equal to the arc cosine of 1/5. Again, that is not a special trig ratio, so we have to use the calculator again. So we're going to say arc cosine of 1 over 5. And there it is, 78.46 degrees. So theta is approximately 78.46 degrees. And last example. Well, don't have to do much here. The trig function is already by itself. So all we're going to do is the arctangent of 5, and that's going to give us our answer. Right? So not a special trig ratio, right? Because 5 over 1, there's no right triangle. There's no special right triangle that has a leg-to-leg ratio of 5 over 1 or 1 over 5. So we're going to say arctangent of 5, and we get 78.69 degrees. Let me just make sure I rounded that correct. Yeah, I did. I'm tripping. Okay, so pretty straightforward stuff. It looks like a lot just because, well, here in the beginning, especially because I showed every single little step, right? But we're all pretty savvy with solving equations. So, in a nutshell, to summarize, how do we solve trig equations? All we're going to do is get the trig function by itself and then do its respective inverse, be that arc sine, arc cosine, or arc tangent to get the missing angle. If it's a non-special ratio, obviously you can just throw it in the calculator. Even if it is a special ratio, you can throw it in the calculator if you're having a brain fart. If you have any questions over this, you know where to find me. Goodbye.